Right. I'll just start. Right. Good afternoon. My name is Haikal, and I work in the client engagement team of S&P Global Sustainable One division. So essentially, we're the division that's responsible for all the sustainability-related data, analytics, and services for S&P Global. My job essentially is to guide our clients on how to use our data and solutions to get towards their objectives. Right. So these clients will range from corporates to the buy side, to your sell side banks, to your pension funds and sovereign wealth funds as well. I cover ASEAN, and my colleague Junhui that you see taking pictures at the back, he helps us manage our business for Malaysia and Singapore. Yep. So today I'm hoping to give you all a high-level understanding on the motivations behind our approach when it comes to assessing asset risk from physical and nature perspective. Now, so sustainability issues, they have gained traction over the years. Regulatory requirements have evolved, right, with the initial aim of getting companies to identify and understand how such risk can impact the long-term success and viability of companies. Now, many of which are crucial to the economies of countries and ultimately the well-being and prosperity of the population. Right now, by and large, discussions around physical risks and more recently nature risks have become more prevalent. Right, as awareness on these risks increase while regulatory requirements on them continue to evolve. So if you look at the table, right, taken from the recent World Economic Forum Global Risk Report, you'll see that risks stemming from extreme weather and biodiversity loss and system collapse have been perceived to be the top two most severe global risks facing humanity over the next 10 years. Now, I believe everyone in this room has become well acquainted with physical risk at a decent level. Nature risk, on the other hand, is still fairly new to a lot of people, right? Judging from the conversations I've been having with S&P's clients in the region. So it is something that's slowly going traction, but still fairly new. Personally, I do think that it will eventually form a key part of one's risk assessment at some point down the road, right? Because as you know, a lot of companies essentially, directly or indirectly, make money by taking something from nature. Now, nature and physical risks, they aren't standalone risks, right? They are interconnected, as you can see from this NGSFS framework. So the degradation of nature and its ecosystems are driven by many factors, among which include, how land use changes as more and more areas become increasingly urbanized due to factors like overexploitation of natural resources, pollution, etc. So this degradation, right, will lead to a decline in the quality of ecosystem services. Now, ecosystem services essentially is defined as the benefits that we humans get from nature. Now, this would include your fresh water, fisheries, raw materials, soil quality, and other natural processes such as pollination. Now, you will see a decline in climate regulation with impacts such as rising surface temperatures, as well as it can also severely impact your hydrological cycle, right? Which is the continuous circulation of water between your Earth and the atmosphere, right? And also, all these, what impact it has, it will also lead to the decline in nature's natural ability or contribution towards carbon sequestration. Now, degradation of nature, right, also gives rise to transition risk as the world looks towards measures to mitigate or restore this decline in nature or the natural environment. Now, maybe one concern we would see is whether we will see any increasingly tighter or more regulation going forward if we continue to remain far away from our carbon targets. Those companies with assets in your protected areas or key biodiversity areas, you also may see them being susceptible to tighter regulations going forward. Now, when you put all this together, right, they present economic risk. Right, as you can see from the chart, economic risk, you see both micro and at the macro level. Now, at the micro level, the more common risks that people will be concerned about are things like your damage to assets, right? Normally from landslides, flooding, wildfires. Now, the most severe of cases may cause these assets to become stranded. Now, companies also run the risk of disruptions in your supply chain, which will impact your production processes and ultimately revenue and cost of your business. Now, increased volatility in the prices of your raw materials, right, is also possible given the instability in the supply. Now, naturally, this risk at the micro level will lead to risk at the macro level, right? As general levels of productivity across the economy may deteriorate. So whatever, if you imagine, if, let's say, an agricultural company starts to see its crop yields going down, that will have spillover effects on other parts of the economy as well, right? Now, as productivity across the economy deteriorate, you can also see increased uncertainties and volatility in inflation levels, among other macroeconomic impacts. Now, on the flip side of things, macroeconomic effects on trade and capital flows, for instance, may impact companies as well. Like if the amount of capital flowing into countries like Singapore, Malaysia, Indonesia declines, then companies will be trying to fight for more capital. Interest rates, simplistically speaking, can be expected to rise over the long term. The cost of borrowing goes up for the company, right? And that ceteris paribus will put your profitability at risk. Okay. Now, for the financial sector, of course, this ultimately leads to various financial risks, such as increased credit risk if companies struggle to adapt their business models in light of these impacts. Things like fire sales of assets can cause companies to absorb significant losses, right? So that's just to provide you a brief background, a little bit between nature and physical risk. Now, I will now share a little on our approach towards how we assess physical risk, right? Now, when we talk about scenario analysis on climate risk, we typically consider both transition risk and physical risk. So transition risks are typically business-related risks, right? As the world and economy works to shift towards a low-carbon economy. Now, this commonly involves changes in policies, technologies, market, right? And we also face risks like reputation. A typical consideration that falls under transition risk would be, what kind of cost would be imposed should carbon prices increase going forward, right? Now, physical risk assessment, on the other hand, essentially seeks to understand how sensitive is your portfolio or your group of assets are to acute and chronic physical risk. Now, if you look at a chart, right, that chart over there, what that describes to you is conceptually, there's a bit of a playoff between the two. Now, imagine a world with low transition risk, right, in the form of, low or negligible regulation or policies, or poor development in green technologies to facilitate, this shift towards a low carbon economy, right? One can expect much higher physical risk as a result in the long term. Now, for example, if you remember that previous slide, this NGFS slide earlier, right? If you allow companies to continue to exploit land or continue degrading environment in, say, one of your key biodiversity areas, right? You can expect various impacts such as rising surface temperatures, and also a reduced ability or contribution from nature towards carbon sequestration, right? Now, on the flip side, higher transition risks could mean effective regulation and policies that facilitate the transition to a low carbon economy. And also, it could also mean increased investments and advancements in green technologies. Now, all of these put together are likely to lead to significantly lower physical risk in the long term. Now, but there is, of course, the question of unnecessary regulation over-regulating, right? Which remains a tricky issue to navigate because it is quite difficult to say at this point in time how much is too much. So I'm just going to introduce to you a little bit about the S&P's Climate Center of Excellence, right? So this is where our scientists and strategists sit. These are the people who essentially do the research, analysis, testing, and this is where a lot of our nature, climate methodology data, research, and processes happens, right? Now, some of these people, they've won like, they're recipients of those IPCC Nobel Prize winners. And whatever research methodology they do, this is essentially forms the backbone of our data and analytics that we offer to our clients, right? And I'll give you guys a taste of the approach in a bit. So this is the chart that shows you the shared socio-economic pathways that's used in our climate modeling, right? Generally, these are driven by several variables, but mainly temperature, precipitation, sea level rise, and sea surface temperatures. Now, if you look at the chart on the left-hand side, sorry. Now, further out on the x-axis you go, it reflects increasing challenges to adaptation. Further, the higher you go on the y-axis, reflects increasing challenges towards mitigating climate change. Now, SSP1 on the bottom left, now this presents the ideal scenario, which will hopefully take us towards our targets of limiting temperature rise in this century to 1.5 degrees Celsius over the pre-industrialization period. But the interesting thing is, like, given the developments in recent years, and some say in recent weeks, now one might say we are currently moving or are already in SSP3 scenario, right? This SSP3 scenario essentially lists barriers to international trade, high inequality, low population growth in high-income countries, and high population growth in other countries amongst its characteristics, right? And I'm sure a lot of you by now are pretty familiar with this phenomenon, right? It's what you're looking at right now. So, best case scenario, we keep temperature rise to 1.5 degrees Celsius and sea level rises by 28 centimeters. Worst case scenario, temperature rises by more than 5 degrees Celsius and sea level rises by about 68 centimeters, right? This is what the NASA projections that we're using are showing. So that this climate modeling bit, right, essentially forms the first part of our approach when we assess physical risk at the asset level, right? That's the top part of the diagram that you see. Now, the next step is we will then need to use asset level data, right? Now, asset level data comes in two forms primarily. The first form is S&P traditionally, we are known for providing financial data, fundamentals data, and we have a lot of asset level data in our system, already in our system, right? So it's either coming from that, or we also use the asset level data provided to us by the clients themselves, right? Because there's no data provider that can say they have 100%, right, of data. We have very good data, we don't have everything. So this asset level data is used to help our clients understand the exposure of those assets to physical risk. Now, in terms of asset data, right, as a minimum, we'll need ideally the asset's latitude, longitude coordinates for the best accuracy. Address works as well, right, but it might be less accurate. So for addresses, but what I mean by less accurate is this: there are nuances across different countries. So in Singapore, right, our postcode reflects the actual block that I'm staying in. In Malaysia, I understand your postcode refers to a certain area or district. This is what I mean by that, right? And if your district is very big, then it might cause issues. And also, the address also depends on what Google gives you, because we're using the Google search engine in our platforms. So the acid test that I tell our clients is, if you copy and paste the address into Google, and Google doesn't give you the exact address, you are going to get the same thing in our platform, right? Which is why latitude and longitude coordinate for us is ideal. For Singapore, Malaysia, Indonesia, not too bad, because our addresses are in alphabets, so it's not too bad. But let's say, for example, Vietnam, Thailand, where from the original language converted to alphabets is not very accurate, that will cause problems as well. Right, so that's coordinates. We also need to know the asset type and asset value, right? And then once we have all that, we can then quantify the financial impact from the assets exposures to various climate hazards. We currently cover 9 climate hazards, including flooding, temperature rise, landslides, wildfires. Now, this financial impact, right, will come in the form of capital expenditures, right? For example, your cleanup and repair costs after a flooding event, operational expenditures, such as cooling, rising cooling and ventilation costs due to rising temperatures, and also business interruption, right? For example, in the event of a flooding, you might need to close your retail outlets. So just to give you a background of what goes on in our system, right? So this is an example of what a flooding map looks like. In this case, it is a flooding map of both Peninsular Malaysia and East Malaysia. Now the colored pixels show you the areas where flooding is projected to happen, in this case for the 2040 decade. Now the fluvial flooding is represented by the tiny pink pixels that you see. Now the larger orange pixels shows you pluvial flooding. Now the difference in pixel size is actually due to the resolution of data, right? What I mean by that, so in our system, fluvial is currently 1 kilometer by 1 kilometer. Pluvial flooding is 25 kilometer by 25 kilometers. Now you won't be able to see the blue pixels, the blue coastal flooding pixels, because the resolution for that is actually 90 meters by 90 meters. So you will need to zoom in a lot further on this map to be able to see it. Okay, now this difference in resolution, right, is actually due to data availability and data acquisition, which we strive to do on an ongoing basis, right? Will resolutions improve going forward? Hopefully, yes, right? But right now, we are basically just using whatever data we have available to provide it. So that's just for flooding, right? So imagine after, and we're doing it across all the 9 hazards. Now, after we identify those 9 hazards, right? Which of these hazards apply to that particular asset in that specific location? We are now next able to identify what are the financial impact to that asset. Now, in this case, we are using the example of urban high-rise office building, and we are taking only flood. Right, so this is what happens in the background of the system. So coastal flooding impact on urban high-rise is expected to lead to cleanup costs, repair costs, rental income loss, and foundation damage. Right, this is the projection or estimation as per our methodology. Right, you may see other people with other methodologies, but these are ours. Now, the nature of these costs are actually different. Some of these costs increase your CAPEX or OPEX. Some of these will decrease your revenue. Now, whatever these costs might be, for across all hazards and all assets, all this financial impact will be summed up collectively, and it will be called as the overall model average annual loss percentage, right? Or MEL for short, as you see on the box on the extreme right. Now so this next slide actually illustrates to you the calculations that goes on in the background, right? You will see this in our platform. These are actually the screenshots from our platform, and I'll explain each of these screenshots from left to right. So on the left-hand side, this one, you will see the overall financial impact of the asset. In this case, what it's saying, for this office complex in Malaysia, is expected to see a MAL, or model average annual loss, of 2.3% through the 2040s decade, right? Now, the chart below that 2.3% that you see shows you the profile of the financial impact on this specific asset, how it's projected to change all the way through the decades through to 2090. Now, this chart is unique to each asset and each location. What that means is that if, let's say, Pavilion KL, that exact coordinate, if instead of a shopping mall, I replace it with a data center, while the hazard that's going to happen to that area is the same, right? Logically, the financial impact will differ because a data center and a shopping center will have different costs, right? And they have different reliances and dependencies. Data centers a lot more reliant on water compared to shopping mall, right? Just a simple example. Now the middle chart, right? All those hazards. So this is as complete as it gets. The only thing that's missing here is landslides, which came live this year, and wind change, which is currently in beta testing on our platform. Now, this middle part, right, it essentially shows you the financial impact that has been attributed to each hazard on this specific asset. The magnitude of this number will indicate to you which are the salient hazards, right, that will cause the most significant financial impact on this asset. So for this office building in Malaysia, temperature extremes is at 1.8%, pluvial flooding is at 0.4% for the 20s, 40s decade. So these two are the most salient for this asset in this decade. Now the two charts on the extreme right. So this one illustrates the calculation that's running in the background for all the assets that you have uploaded. For most of our clients, especially for your global banks, so this is one asset, they will upload hundreds of thousands of assets, right? So this same calculation happens across each and every one of the assets. Now the two charts on the right, shows you the link between the projected change in hazard and what are the respective financial impacts. So in this case, we are talking about temperature extremes specifically. The chart on top, right, shows you how, in this case, temperature extreme is expected to change through the decades, through to 2090s for this particular location. Right now, I'm projecting for 2040 here, as you can see, 2040 to 2049. So on the top chart, you will see on the x-axis, it has 2020 all the way to 2090. So 2040 is roughly 2, you will see, right, the red line is about 2. So what that means is, for temperature extremes at this location, average temperature is expected to rise by 2 degrees Celsius for 2040. That is essentially what this chart means, right? Now the y-axis value on that top chart, the 2 degrees Celsius, will then become the x-axis value of the chart at the bottom, right? And this chart at the bottom will show you what are the projected costs as a result of this 2 degrees Celsius rise in temperature. Now, in this case, the most significant cost attributed is actually HVAC degradation, which is the yellow bit that you see on the chart. So we have cooling costs, employee productivity, HVAC degradation in yellow. These are the projected costs that's expected to happen due to this rise in temperature change, right? So this is roughly the calculation that happens on the background. So if 2040s, it's 2 degrees Celsius, I think 2090s is about 4 degrees Celsius, so this is how it works. And therefore, the y-axis value of the chart on the bottom, right? Remember, this is for temperature extremes. So for 2 degrees Celsius, the y-axis value is 1.8%. That's the value that you see for temperature extremes, right? So this is just to explain to you the calculations that goes in the background and how this 1.8% number comes about, right? Similar concept happens across all the other hazards. Now, this is the last slide I'm using for physical risk. Now, it's just a simple analysis showing you what average financial impact at the company level looks like. So for this one, just a couple of points. To do this, I just use a small subset of about 19,355 listed companies. Right, the overall coverage we have for physical risk data in total is about 800,000 entities. Right, I'm just using these 19,000 listed companies. Now this is based on, first of all, the companies and their assets that we have on our database. The 3 different colors that you see shows you what the average company level financial impact for 2030s, 2050s, and the 2090s decade across 3 major regions, as well as the ASEAN 5 economies. So for APAC, your average company level financial impact in 2090 is about 7.6%. North America, which is US and Canada, 11.62. Now note, these are company level, right? So that means North American companies might have assets all over the world, but we are doing this at the company level. If you rerun the analysis by where the asset is located, numbers will be different. Okay, so just take note of that, right? Now, ASEAN 5 companies, as you can see, Indonesia has the highest average impact, 8.68%. Malaysia second highest at 7.72 for 2019's decade. Again, these are Malaysian companies. So, I mean, of course, you can run your own more complicated analysis using your portfolios, or your portfolios using this same data set as well. But this is just a very simple illustration, right? So that's for physical risk. I'm moving on to nature risk next. I'll just show you guys a few examples, just to illustrate how nature plays a crucial role in our transition to a low carbon economy. And also, this will provide a background behind the nature risk approach that we developed with the United Nations. Now, it's common knowledge, right, that nature plays an important role towards reaching net zero goals. Now, the chart that you see here from IPCC and NASA gives you an idea of how much, roughly, that our natural environment contributes to carbon storage. Now, how well soil stores carbon is dependent on factors like soil type, vegetation, and climate. Generally, the wetter and colder, the better is the soil's ability to store carbon, right? Which is why you see wetlands are seen to be able to store the most carbon at about 643 gigatons. Now, our forests roughly contribute about 15.6 gigatons of carbon dioxide storage each year. Now, that's roughly 3x of the US's annual carbon emissions, right? Now, however, this bit of research says or purports that about 8.1 gigatons are actually estimated to leak back into the atmosphere each year due to various types of disturbances. This could be fires, deforestation, right? Which is not exactly helpful towards our plight to mitigate this rise in temperatures. Now, one example of human activities that significantly alters your natural landscape are mining activities, right? Now, if you look at this chart here, the areas in darker green, indicate those areas that are as close to their natural habitats or environments as possible. The ones in purple are showing you the environments that have been modified from their natural habitats. Now, I would like you to direct your attention to the bits in red, right? Which reflects potentially modified natural habitats, especially the parts in North and South America, as well as the western and eastern coast of Australia. So if you remember these red parts, right? Now this next slide shows you mines in different stages of development, from closed mines to operational mines. Now the parts in yellow shows you the mines which are in the exploration stages. That means these are mines that are not fully operational. Now, if you look at the yellow bits, a lot of them overlap with the areas in red. Right? Now, roughly 60% of these exploration stage mines are in these areas. What this hints to you is there will likely be further considerable degradation of the natural environment going forward, especially when these mines finally become fully operational. Right, and of course that will lead to your spillover impacts, like the ability of nature to help us capture carbon. But it's a bit simplistic to say that we should ban all mining activities, right? Because the ironic thing is that materials required to help us with energy transition, at least using current technologies, can come from mines located in key biodiversity areas. Like, for example, in this case, roughly 29%. So you see all these materials, you recognize lithium and cobalt, for example. They are key elements in the production of your lithium-ion batteries that you find in many things, including electric vehicles, as well as a lot of your energy storage systems. raw materials aside, even these assets, right, that help us to generate renewable energy can also pose substantial risk to nature and result in substantial nature degradation. So this graphic, it actually shows you the location of power plants in Europe. Renewable power plants are the ones in yellow. Non-renewable power plants are the pixels in red. The areas in green shows you where the key biodiversity areas are in Europe. So based on this research, you will see that about 12% of your renewable power plants in Europe are in key biodiversity areas, compared to just 3% of non-renewable power plants. So the question is, can we just simply shift these renewable power plants into areas which are less harmful to biodiversity? It's not a simple yes, right? Logically speaking, because a lot of these power plants are actually built near or around its sources of energy. You cannot build wind turbines in areas with little to no wind. You cannot build hydropower plants in places with no access to flowing water. That's just pure logic, right? So it's not like you can shift this anyway. So you can see like how all these things, it presents governments, companies, NGOs with a difficult conundrum of essentially how to balance the risk to nature degradation and the transition to a low carbon economy, at least based on current technology levels. It might change in the future, no one knows. So this identification of assets and their relationship with nature, now this forms the basis of your LEAP framework in TNFD, right? Locate, the first part, essentially involves or asks companies to identify and understand where your direct assets and operations and value chain activities are. What is the state of the natural environment in these locations? Whether or not you're operating in any priority locations, right? Priority locations meaning areas of high biodiversity importance, or areas which are seeing rapid decline in natural environment. And of course, which of your business units or part of your value chain are also operating in these areas. Now, a lot of the next step, the evaluate step, involves understanding which of your business processes and activities are in these priority locations, what type of environmental assets or ecosystem services that they rely upon or could potentially or already having an impact on. Right now, locating and evaluating, at least from a nature risk perspective, is the easy part because there's already data, some data to help you understand and quantify those, right? So like our nature risk data essentially is geared towards helping companies out in the first two stages. The assess and prepare stages are a lot trickier because then you'll need to think through like how to assess how these risks are expected to develop going forward. Once you do that, you need to decide what type of actions you need to consider to mitigate this risk, right? But it's not all risks. There are also some opportunities that can help companies to make money, depending on what businesses or sector you belong in, what technologies or expertise you have, and what you can acquire. Yeah? So having a good, hopefully a good understanding of what your exposure to nature is, right, from a company level, can help to guide or inform decision-making processes, to ensure, not say ensure, but to give a higher probability of longer-term success and longevity of the company, right? Because like I mentioned at the start of my talk, a lot of companies directly or indirectly make money by taking something from nature. So in 2023, we officially launched the United Nations Nature Risk Profile Methodology, right? This is something that we worked on with our United Nations Environment Program counterparts. So the aim of this is actually to provide you with, provide our clients with data and intelligence, right, on the relationship that these corporate entities have and their assets have with nature. Generally covering two aspects: what impact these companies and their assets have on nature, and number two, which of the ecosystem services or the benefits that nature provides us are these companies and assets dependent on, and what is the severity of this dependency? Now, how we quantify this relationship is illustrated on this slide, right? Now you will see on the left-hand side factors contributing to the magnitude of impact an asset has on nature. Those factors on the right will inform our clients, what is its dependency of nature, right? So under magnitude of impact is measured by this metric called ecosystem footprint. It's a combination of two things: land use, significance of locations. Land use is essentially how much that bit of land has been degraded as measured by the ecosystem integrity index. Now this index, in a nutshell, it aggregates the structure, composition, and function of the ecosystem, taking into account human pressures, right? It's on a scale from 0 to 1. The higher the score, the better is the integrity of the land. If you are keen to know, composition actually refers to the identification and the abundance and variety of life in that area. Structure, it's more of how the ecosystem is organized, right? Your biodiversity, species composition, vegetation layers, right, and population density as well are some of the factors. Function refers to processes such as water flows, pollination, and energy transfer. Right, so that's for land use. Significance of locations is simply the ecological importance of a given area that has been impacted by company activities. So generally assessed through two dimensions, species significant index, and as well as the ecosystem significant index. So species are for your biodiversity conservation. Ecosystem significant index is the significance that this area contributes towards the benefit or well-being for human beings. On the nature side of things, right, on the dependency side of things, this is quantified across 21 various services that ecosystem provides us. So this would include soil quality, pollination, groundwater, and mass stabilization and erosion control. Essentially, what we are quantifying are two things, right? How dependent, in terms of reliance, how dependent are the company's activities across each of these 21 ecosystem services? And then for resilience, whether or not these services can continue to provide, right? If, in a simple example, if that area of land has been very degraded, resilience is very low. You take a hydropower plant, for example, which has a very high dependency on water. So if this plant is located in an area that becomes water stressed, resilience score is likely to be very, very poor, right? That's roughly how this thing works. So in terms of, this is just a graphic to put some of this data into context, right? If you look at this graphic from the UNEP, areas in dark blue will reflect a score close to 1, which essentially reflects an area that is as close to its original or pristine state as possible. So if it's a rainforest, it remains as close to a rainforest as possible. If it's a desert, it still remains as a desert as close as possible. Areas in yellow reflect areas with scores that are closer to 0, right? So basically, very little integrity of the land compared to its pristine state left. So generally, the more urbanized the area is, the more likely it would have been degraded from its original state, right? So large cities would be good examples of this. So we do have some research, right, that makes use of all this nature risk data. Right, now on the impact side of things, one of it is just under half of the world's largest companies have at least one asset located in a key biodiversity area. Right, so this leaves them exposed potentially to reputation risks and risk of tightening regulations covering such areas going forward. Now, depending on how severe these regulations may turn out to be, right, it could impact company operations in these areas significantly. Maybe even to the severe extent of forcing the closure of key factories or production sites in such areas. Right? Some of the industries that probably comes to mind are mining, your timber industry and all that, right? And the other side is, for this research is based on 2021 data. So in this one, world's largest companies are found to have used about 22 million hectares of land to collectively generate about 30 trillion USD in revenue. So when we express this as our impact metric, right, that the thing that we call ecosystem footprint, which I mentioned earlier, takes into account land use as well as significance of the land, it is essentially effectively equivalent to fully degrading roughly about 2.2 million hectares of land of some of the world's most pristine ecosystems, such as though you might find in the Amazon or in the rainforests of Sumatra. And then on the other side, when we look at dependency, roughly about 85% of the world's largest companies were found to have a moderate or high dependency on nature for their direct operations. Now, for the dependency metric, a score of 0 represents no dependency risk. A score of 1 represents very high dependency risk. When we say moderate or high dependency, it's a score of 0.6 and above, right? So collectively, the ecosystem service that these companies were found to be most dependent on is the flood and storm protection ecosystem service. This one refers to the sheltering, buffering, and attenuating effects of natural and planted vegetation. So for S&P, right, how do our clients actually use our data for both physical and nature risks? Generally 2 ways, right? Number one, the first method is the reporting service. So this is where our team works with our client to understand and assess the risk, regardless whether it's physical or nature, and put this in the report. So our clients that use this are usually your companies who are doing it for the first time, who are new to concepts or need guidance to ensure that they're moving in line with accepted practices and standards, right? There are also clients who use this because their management wants an independent outsider analysis with regards to their company's exposure to physical and nature risks. Usually this is done to see whether internally they are drastically underestimating or overestimating certain risks, right? And of course, there are those who are just happy to hand this off to us because it's just more convenient and economical to do so. Now, the findings, I'm just showing an example. The findings are consolidated in this kind of report. It puts into the report the context to help make sense of the data. Now, this example, nature risk, like the middle portion, which shows you the impact risk part, right? Essentially, in this part, we indicate that this company has an impact ratio of 0.06 times, which essentially means very low impact on nature. The bottom dependency risk part of things shows the company's overall dependency score, how many of the ecosystem services is dependent on. In this case, for this company, it's 12 out of 21. And what is its overall dependency level, right? Now, of course, we also provide the underlying data sets and platforms for our clients to upload their data to view and extract all the underlying physical risk and nature data. So our clients who normally use this method have either already done their initial report and wants to do their own analysis, right, for the corporates. For the larger funds, the larger banks, they will use the data that we already have together with the platforms to do their own analysis on their portfolios, right? So for example, for the banks, they might use our existing data to do a physical risk analysis on companies, and then we'll use the platform to upload their mortgage book, for instance, right? So, I mean, that's all I have for today. I hope it's been useful to provide you guys with an idea of physical and nature risks and a high-level understanding of our approach to them. So if you have any questions, or if you want the materials, or you want to engage in deeper discussion, there's that QR code, which will get you in touch with my extremely good-looking colleague, right? So he handles manages our business for Malaysia and Singapore, right? And he can essentially, how we work is, if you have a point person there, he's responsible for bringing the correct team or correct experts to the corporates, right, to help you address your questions. Right, so if there are no questions from the floor, thanks very much for spending your time. We appreciate it. and enjoy the rest of your week, guys.